Hey everyone, welcome back to the fourth episode of the Tensorflow for NLP tutorial series. In the last few videos, we built Word2Vec, but didn't ever really do anything with it. So what we're going to try to do today is actually apply what we've learned. What we're going to do is we're going to try to build a sentiment analysis classifier using Word2Vec. What we're going to do is we're going to try to see, can we find out if a given review is positive or negative just based off of the text? Let's jump right into it. All right, so first things first, what we're going to have to do now is we're going to have to change our preprocessing. Before, we were just having word pairs being passed into our model, but this time we're going to have sequences which represent sentences. So in order to do this, we're going to use the Keras tokenizer class. But one of the limits that I've found with it is that it actually doesn't have functionality for taking out stop words or meaningless words. So we're going to have to do that ourselves. So what I have here is our data helper library, and I took out that function that I had in there last time. We're going to build this from scratch. Okay, so first and foremost, we're going to have some import statements. So from Keras, preprocessing, import tokenizer, and then we're going to import some NLTK stuff, and this is going to be for getting rid of those stop words. So NLTK import word tokenize from NLTK.corpus import stop words, and then import string. And I'm going to go ahead and copy paste a little bit of text into here. And these are the sentences that we're going to play with just to see what this is doing. And now we can create our function. So we're going to call it Tokenizing Process. So let's build that. It's called Tokenize and Process. And we're going to pass it text, which is going to be a list of sentences. Just like this variable right here. And we're going to set a vocab size parameter, which basically will limit the vocab size if we want to. So here, we'll set that to 10,000 for now. And that'll make a little bit more sense later, but we'll just go with it for now. So first we're going to create a list that will hold our clean text. So we'll hold clean text, and we'll say text clean equals new array. And then we're going to amass a list of stop words. So what we want to be able to do is have a list of words to check across a sentence. So maybe we want to take out I because I is a pretty common word. Or maybe we want to take out all commas. Or maybe we want to take out these apostrophe S's or these contractions here. And that's what this stop variable will be. So this is going to be a list of stop words or unwanted words. And we're going to say stop words dot words English, which would get those from NLTK. And we're going to also add in some punctuation from the string library. Okay, and now we have all of our stop words in a list. And basically what we want to do from there is we want to be able to iterate through all our sentences. So look at each sentence. So look at this one and erase the stuff that we don't want, and then go to the next one and do the same thing. And we're basically going to create a new list that's going to be taking out those things. So maybe we don't want this, maybe we don't want this, and it's going to create a new sentence like that. So for T in text, we're going to say text clean dot append, and this is going to be a really huge and kind of crazy line of code, but I'll try to explain all of it as we go. So first we're going to say we're going to open up a string with just a space, and then we're going to say dot join, and then we're going to have a list comprehension right inside of here. So I'm going to go ahead and just do this real quick. And then I'm going to close this. And then inside here, we're going to write I for I in word tokenize T dot lower if I not in stop and I 0 does not equal. And then we're going to open up a double quote and then put a single quote inside of it and then another double quote. Okay, I think that works. So this line of code, crazy. I'm sorry. But basically what this is going to do is first we're gonna tokenize the words. So it's gonna create a list of each word that's inside here, and it's gonna be the lowercase version of that. And then we're going to see if it's in our stop word list. And if it is not, then we're gonna add it onto this string. And also additionally here, I added this part because I found that by doing the first part here, it still leaves like apostrophe S and apostrophe RE or something from different words. So this will get rid of that. After that, we're going to instantiate the tokenizer from Keras. So that's this guy up here. So we're going to say instantiate tokenizer. I'm going to say T, capital T, equals tokenizer. And what you have to pass this here is the vocab size that you want to limit it to. So if you end up having 50,000 different unique words, we want to be able to cut that down to just the words that are the most frequent. And that's why we had to remove the stop words, because otherwise those would be included inside of our cutoff vocabulary. So this way we've already taken out the useless words, and then we get the 10,000 most frequent words that are not stop words. So we'll say num words, that's the parameter, equals vocab size, which again we instantiated when we made this function. All right. Now what we're going to do is we're going to fit the tokenizer with the text that's incoming. So basically we're going to say t.fit on texts, and then we're going to say text clean. So what this is going to do is it's going to kind of take the text that you have and create those index word pairs. So we can say now that you know, jumped is now index 530 or something. Obviously in this case it's going to be a lot smaller because we don't have that big of a vocab size here. But when you're doing it on the full data set, it'll be doing something like that. And now we're going to turn our input text into sequences of index integers. And this is what we want, right? So we want to be able to take a given string, like, I don't know, the string here, and then just turn it into a list of integers, right? So that we can pass it into our model. And that'll be data equals t dot texts to sequences. And we're going to pass that our text clean. And that'll take each cleaned text and transform it into sequences of integers. And now the next couple things we're going to need to do are get the vocabulary word and index pairings out of our tokenizer. This is so that we can translate to and from words and integers. And the way to do that is word to idx equals t.word index, and idx to word equals, and this is something I found on Stack Overflow, and basically it's just going to flip our dictionary keys and pairs. So now we'll be able to say we can go from an index to a word instead of a word to an index. So to make that make a little bit more sense, here it would be something like, our dictionary would look something like jumped is 1, 2, 3 or something, and this one instead would be 1, 2, 3 jumped. Okay, so basically we can go back and forth either way, whatever we want. Okay, and finally we're just going to go ahead and return our data, which again is our sequences of integers now, our word to idx, our idx to word, and our tokenizer object. Okay, I kind of figured you guys might want to know what this looks like when it runs, so I'm just going to run it real quick. And basically, our text is just a list of sentences. And if we say data, word to idx, idx to word, and then t equals tokenize and process our text, our data is going to be transformed into these list of integers, which is exactly what we want. And just to show you, the word to idx, again, is going to be those words paired with the value of their integer. And The opposite of that is going to be the IDX word, which is just the exact opposite. So if we see here fits and 6 should be the same as 6 and fits. There we go. Yeah. So yeah, that's exactly it. And if we want to make sense of what's exactly happening in here, I'm going to just grab a couple things here. So first was that list of stop words. And again, that just looks like a bunch of random words that we want to take out. So a lot of these words are just useless, and the punctuation is useless, and it's just going to get in the way of our analysis, and it's going to be better if we take them out. The other thing I wanted to clear up was that monstrosity of a line of code. And to show you that, I'm just going to say t equals texts 0. Whoops, t equals text 0. And again, that's just a sentence. And so that crazy line of code we did here, what this is saying is, let's take the lowercase version of this sentence, and let's see if one of these stop words is inside of it. And if it is, then don't add it onto the string. And if it isn't, then go ahead and add it onto the string. And if you don't know what the join method does, basically what it's doing is it's going to take a list of words and it's going to create a string out of it with this, whatever's inside of here, connecting them. So to be a little bit more clear, I'm going to grab this and just show you. Yeah, so that's basically just creating a list of the different words that were inside the original sentence, and then it's going to take out whatever's inside the stop list, and then it's also going to take out any word that's in that has a apostrophe in it right here. All right, I think we're going to call it here on this video. Today, what we did is we took sentences and we transformed them into sequences of integers, and in the next video, we're going to pick up with creating the labels for our reviews based off of their star ratings, so we know which reviews are positive and negative, and then we can create our sentiment analysis classifier based off of that. I'll see you guys in the next one, and thanks for watching.